Welcome back to Pre-Calc in Pajamas! Hi everyone. I'm gonna let you know right now, this is probably gonna be one of the more hefty videos. I have a lot to go over. It's really not that hard because you already know trig and you're really good at trig. It's just, this is when math starts to look more scary, and I don't like it when it looks scary, but you guys are going to be fine. You just need to trust in your trig skills and understand that, like, this isn't that bad. It's just a lot to go over, and I want to give you examples of each. So, guess what, guys? We finally got to vectors! I'm so excited. I've been waiting a long time to get to vectors, because you're going to be using vectors in physics. Next year, you're using it in physics. End of story. I want to give you a little heads up, and you actually are really lucky that this is a video so that next year when you're taking physics and you forget all about vectors, you can come right to this video and just kind of refresh your memory. So before I get started, there's a couple different ways that you're going to see vectors written out. So vector itself can either be like a bolded letter, or you're going to see it with the vector symbol on top. So it can be bolded, and then you'll know it's a vector, or it can be this. I don't care what you use. I'm going to be doing the little arrow on top, the vector sign. I'm going to be using that. But if you're feeling fancy and want to bold your stuff, because it's all on Google Docs anyway, do you, bro? So that's the way that we're going to identify a vector. So there's a couple different ways that they're going to give you information about a vector, which is basically its end point. So there's the initial point, which for us is always going to be at the origin, and then there's the terminal point, which is the end point. So the way that we're going to be using it is I'm going to say vector 3, 4. And these are called angle brackets. And this is what I'm going to be using. I'm going to be using the angle brackets because the angle brackets tell us that it's in standard form. And standard form just means it starts at the origin. That's it. You can have a vector that starts at 1, -7, and cool. But all the vectors we're dealing with are starting from standard form. So if you see the angle brackets, that just means it's starting at the origin. Another way to do it is you could say vector 3, 4. You could just use normal parentheses. That's fine. You may also see it if you ever take linear algebra. I'm super bummed that we're not going to get to matrices, but you could see it as this 3, 4. X, Y. We won't be doing that. I'm really bummed that we're not going to get to it, but I think the vectors are the most important thing because it still picks up on your trig skills a lot. I'm sorry about the lighting. It's kind of weird. There we go. It's kind of going in and out. You'll see. And then the last way that you can see it is with I and J. And that's because these are, I believe they're called unit vectors, and this one is about the x-axis, and this one is about the y-axis. So 3 times 1 is 3, 4 times 1 is 4, 3, 4. Cool. Well, we're going to be dealing with the angle brackets. I love them. They're just fun to draw. So that's what we're going to be using. So the first thing, I'm going to go in order of the Cartesian plane. Yeah, we're going to go quadrant by quadrant. So if you think back to our unit circle, this was 0 degrees, but it was also 360 degrees because it goes all the way around, right? This is 90 degrees. Then we got 180. Then we got 270. So I'm going to graph on this 3, 4. Vector 3, 4. I'm going to go over 3. I'm going to go up 4. And here's my vector. Hello, vector. Nice to meet you. But the amazing thing that happens here is when I look at this, I can draw a line to my x-axis, and I have a right triangle. Yay! So because they're both positive, they're in the first quadrant, I'm going to define magnitude and direction as I go along. But we're just going to I'm going to quick remove this. I don't need this whole big graph thing, right? So I'm going to get rid of my big graph thing. And I'm just going to draw a triangle, right? So it goes over 3, goes up 4. And theta will always come from the origin, right? So if this was on the Cartesian plane, go over 3, up 4, have your little triangle. And since the origin is right here, I'm going to put theta there. Great. So there's 2 words that I'm sure you have seen, and it's magnitude and direction. So a vector has to have those 2 things. It has to have magnitude, has to have direction. So the example that everybody uses is if I said I'm driving 5 miles an hour, that's telling me the magnitude, that's telling me the length. It's going to come back. But it's not telling me where. I could be going 5 miles an hour north, or 5 miles an hour south, or southeast, or northwest, or 30 degrees south of wherever. And that's where the direction comes in. And I'm sure that you can guess that he's going to help us find direction. So in the first quadrant, that just is direction. If it's in the first quadrant, your theta is the direction. Boom, done. Because the direction is always going to start in the first quadrant and go wherever it goes. So if it ends in the first quadrant, it's going to be theta right there. It's really tiny, but I'll make it bigger, I promise. So if it's in the first quadrant, and I can actually do it here, because now I'm regretting not having it there. In the first quadrant, yay, we got theta here. So my direction will be from the x-axis to there, which is why you can see that theta will be direction. Magnitude is just a fancy way of saying how long is the vector. The magnitude. So the magnitude is always going to be my hypotenuse, and we have skills to find the length of a hypotenuse. It's called, and I can hear Makai right now, Pythagorean theorem. A squared plus b squared equals c squared. Give me light, give me light. Yeah. A squared plus b squared equals c squared. Doesn't matter if this is a or b. I don't care. Doesn't matter. I'm going to call him a, I'm going to call her b. And we're going to figure this out. 3 squared plus 4 squared is 9 plus 16, which gives me 25. I started you out with a Pythagorean triple. The square root of 25 is 5. So I'm going to show you the way that we would write magnitude. And there's 2 ways to do it. I'm going to show you my way. And then I'm going to show you another way that some math teachers will use it so it doesn't get confused with something else. So if I know that the magnitude's 5, I'm going to write it like that. And it's an absolute value symbol, but it doesn't mean the absolute value of a vector is 5. It just means the magnitude is 5. Some mathematicians don't like that they're so similar, so they'll write it like this. And it is the same exact thing. You can do one little line, you can do two little lines. I don't care, they're both correct. So we have the magnitude. So I'm going to go back to my triangle. Now I know the magnitude's 5, so I know my hypotenuse is 5. And I need to find theta, because theta is my direction. So I can use any one of my inverse trig functions. I'm going to label my sides so you can see them, and then you can pick whatever one you want, and then just do that. Cool. So 4 is opposite, because it's directly across from theta. 5 is hypotenuse, because it's directly across in a 90-degree angle. And then 3 is adjacent, because it is adjacent to that. Cool. So I'm a sine gal. Like, I like using sine. I'm going to use sine. So I would use the inverse sine of opposite over hypotenuse. If you are a cosine guy, you're going to do adjacent over hypotenuse. You're going to do the inverse cosine, I should say. And then if you like tangent, I'm going to be using tangent after this one, and I'm going to show you why. But if you like tangent, you can just do opposite over adjacent. Boom, done. But no matter what one you use, should be the inverse, because the inverse finds the angle. So I'm going to quick do that inverse sine, 4 over 5, and that gives me 53.13 degrees. And because it's in the first quadrant, easy peasy, we're done. So I'm going to say that the magnitude is 5 and the direction is 53.13. The first quadrant is your friend. We like first quadrant. Please be light. Give me light. Yeah, thank you. We like the first quadrant. It's easy peasy. The other ones really aren't that bad. You just need a visual to understand what's going on. So that's first quadrant. So I bet you can guess what's coming next. Second quadrant. Where's my second quadrant? Boom, there she is. So again, we have our, I'm gonna do that really quick. We have our unit circle with all of our things. This is the first quadrant. This is the second quadrant. So we know that theta has to be between 90 and 180 degrees. Our direction has to be between 90 and 180. So the issue is that our theta is not going to be between 90 and 180. And I'll show you how to fix that. Just keep that in the back of your noggin. So second quadrant, let's say, and I took this directly from the PowerPoint. So the examples I'm doing in here are the examples from the PowerPoint. We're going to do vector -6, 2. Vector -6, 2. So let's put that on a Cartesian plane. I do this sometimes. So it's there in the second quadrant. We went over -6, we went up 2. So our triangle will look like that. And I'm going to draw a bigger version of our triangle. Let me just quick look something up. Yeah, cool. Okay, so -6 here and 2 is here. Now what you may notice is that I did not write -6. It's in the negative direction, but the length is 6. Length can't be negative. It's just telling me direction by saying it's negative. So I'm going to, when I rewrite my triangle, I'm going to have a 6 here and not a -6. Also, it doesn't quite matter when you're solving for magnitude, because when you square, it makes it positive anyway. But it'll totally mess up with your theta calculating later on if you kept the negative. So, rewind. Cool. Theta needs to come from the origin. So theta is going to be here. And we're going to solve for magnitude the same exact way. A squared plus b squared equals c squared. So I'm going to do 2 squared plus 6 squared equals, that's 4 plus 36 equals 40. Take the square root of 40. Why didn't I solve this earlier? And I had everything all planned out, and I thought I was on top of my game. All right, so type in 40, then do the square root. 6.32. So my magnitude, 6.32. This is the last magnitude I'm going to do because it's the same exact process, and it'll save us a little bit of time on this potentially very long video. So magnitude is 6.32, which means my hypotenuse is 6.32. But let's say I just asked for direction. I don't care about the magnitude. I'm just trying to find the direction of the vector. That means I'm looking, I don't know if you hurt my stomach, but that was gross. I'm looking for the angle that goes from here to here. But we only know this angle. And that is why I gave you the discussion post that probably seemed very easy, where I said find x, and I gave you that as 30. We're going to do the same exact thing, right? We have a straight angle here. So we're going to subtract theta to get our direction. So we're subtracting this guy from 180 to get what I'm trying to show with the arrow, because the arrow itself is the direction. So first things first, let's find out what theta is. I'm going to use tangent, and I'm going to use tangent from this point forward so that we don't have to find magnitude. Now granted, this week I'm asking you for both, but if I were to just ask for direction, don't worry about magnitude. You have the opposite, you have the adjacent, just use tangent. So that's what I'm going to do. Identify your sides. 2 is opposite, 6 is adjacent. So I'm going to do inverse tangent of opposite over adjacent. Type it in my calculator. I get 18.43 degrees. 18.43 is not my direction. It's in the second quadrant, which means we're going to subtract it from 180 because of this guy here. This is not direction. This is theta, but this is not your direction. This is not the answer I'm looking for. I'm going to look for 180 minus 18.43, which gives me 161.57 degrees. This is my direction. Cool. So we were subtracting it from 180 because that's a straight angle and I'm removing theta. Easy as that. So that's the second quadrant. Third quadrant, let's move on to that. Third quadrant, I gave you the vector, goodness, -4, -2. And I'm going to quick draw a little plane for you. 1, 2, 3, 4. 1, 2. Draw our vector. There's our vector, happy in the third quadrant. Draw from the x-axis. If you draw it this way, theta is going to be all weird, and then it makes it very difficult to understand which ones, like what you have to subtract it from. I like drawing it up to the x-axis or down to the x-axis. And then theta's here, hi theta. But now the problem we come across is how do we find direction from here to here? Well, we know this is a straight angle. We know that's 180. We know theta here is going to help us out. So instead of subtracting from 180, I'm going to do 180 plus theta. So keep that in mind. So now it's a lot to work with in that little picture. I'm going to draw, that's 4, that's 2, got my theta here. So I like redrawing it as its own triangle so that it's not all cramped in that, right? This is opposite, this is adjacent. I don't need to find magnitude, so I'm just going to find direction. You can find magnitude, just use Pythagorean theorem. I believe in your math skills to be able to do that on your own. So I'm going to do the inverse tangent of opposite over adjacent, 2 over 4, and that gives me 26.57 degrees. So that's theta, but that is not my direction. My direction is going to be the 180 plus theta. I love third quadrant. I think third quadrant is nice because it's addition and not subtraction. So 180 plus 26.57. We're going to get 206.57 as our direction. Ta-da! Just add it. Now the last quadrant, you're going to do pretty much the same thing, except we're subtracting it not from 180, and we're not adding it to 180. I'm going to show you what happens. So, it's so dark. Can you please lighten up? I feel like I'm a creepy villain in a movie. Hello, light. There we go. Okay. That's still pretty dark. Whatever. Okay, so the last quadrant, the last vector I gave you in the PowerPoint was 4, -8. Thank you. Let there be light. 4, -8. Great, cool. So I'm going to show you what it looks like on the Cartesian plane, and I'm going to show you what the angle would look, what the triangle would look like, and then show you how to get direction. So let's put it here. Cool. We go over 4, 3, 4, go down 8, 1, 2, 3, 4. Oops, 5, 6, 7, 8. Remember, I always said draw it to the x-axis. So I'm going to draw it to the x-axis, and theta is here. Cool. So let's draw it as its own triangle because it's ugly looking and a lot to deal with in a small space. So I got theta here, I got 4 here, I have 8 here. Again, you can find magnitude by just doing 4 squared plus 8 squared, take the square root of that, blah, blah, blah. But to make this a shorter video, I'm just going to focus on direction. So remember, 8's opposite, 4 is adjacent. Before I get to theta and solving for theta, I want to show you what the direction is going to look like. The direction is going to be a crazy reflex angle, right? It's going to go from here all the way around. So a full circle is 36. A full circle is 360 degrees. So a full circle would be all the way here. So I'm going to take a full circle and subtract that piece. So I'm actually doing 360 minus theta. That's how I find the direction for the fourth quadrant. I'm not erasing that. I'm just going to continue. All right, so 8 is opposite, 4 is adjacent. So I'm going to do inverse tangent of 8 over 4. And I'm going to get for theta, not for my direction, 63.43. This is theta. This is not my direction. So now to get the direction, I'm going to do 360 minus 63.43. And I'm going to get 296.57 degrees. And that is the direction. Yay! Cool. Awesome. And that's how you find magnitude and direction in all 4 quadrants. Magnitude is the same exact thing. Doesn't matter what quadrant you're in. But with direction, it does matter because the negatives or positives are going to tell you what quadrant it's in. So what I would do when I'm solving the problems I gave you is I'd quick do a little XY boy, do a little Cartesian plane, see what quadrant it's in, solve for theta, add or subtract accordingly. It is going to require a lot of scrap paper and a lot of writing down. I just don't want you to get too overwhelmed. I think you're going to be all right. I think you're going to be great. I think you're going to do wonderfully. So that is the end of my video. I hope it helped. Again, if you guys ever have questions, or you ever need help, or you ever just want me to reteach it, email me or try and set up a Google Meet. I'm more than happy to do them. Just let me know. All right, thank you for watching my video. Bye, guys.